Hello everyone, welcome to this new Blender Geometry Node training series. In this series, we are not just going to create a 3D Rubik cube. We are going to use this 3D Rubik cube as a practical project to understand procedural thinking, logic building, spatial reasoning, and problem solving inside Blender. Many students learn Blender as a modeling tool, and many gamers look at 3D objects only from the final visual output. But behind every interactive 3D object, every game mechanic, every simulation and every procedural system, there is logic, there is structure and there is reasoning. This is exactly what we are going to explore in this project. A Rubik cube may look simple from outside. It is just a cube made of smaller cubes with color on different faces. But the moment we ask a simple question, how do I rotate only one layer? The project becomes much more interesting. Now we have to think about points, positions, axis, selection, rotation, stored values, and how each movement affects the next movement. This is where geometry nodes becomes very powerful. In this first episode, we will begin from the default cube in Blender. We will create the cube using geometry nodes. Then we will generate a 3x3x3 structure by using cube vertices as placement points. After that, we will use instance on point to place smaller cubes and form the basic Rubik cube structure. Once the structure is ready, we will start asking the real engineering question. How can we rotate only one part of the cube instead of rotating the entire object? That question will slowly take us into mathematical thinking, axis control, phase indexing, condition, and later simulation nodes. So this project is useful for engineering students because it improves logical thinking, coordinate understanding, procedural design, and problem solving skills. It is also useful for gamers and game developers because the same concepts are used in interactive 3D systems, puzzle mechanics, animation logic, and real-time control. By the end of this series, you will not only have a Rubik cube model in Blender, you will understand how to build a system. So let us begin the very first step, opening Blender, entering geometry nodes and creating our Rubik cube procedurally. Now let us start by launching Blender. So I have the shortcut to Blender on my desktop. Double click to launch Blender. I have the latest Blender 5.1.2 version. If I click somewhere on this blank area, the splash screen disappears. By default, you have the camera, you have the spotlight, and you have a cube. So I will select this cube. We are now going to do modeling only by using the geometry nodes. So on the top in the layout, you have geometry nodes. Click on geometry node, and with cube selected, you have in the properties panel modifier is on and you have add modifier here. Either I can add geometry nodes through this modifier, or I can come into geometry nodes panel and click on new. The geometry nodes is added in the modifier. Now I will come and rename this as Rubik cube. So I'm not going to use this default cube. You have one group input and group output, and it is connected through the line. You have an input geometry which is giving the output. I have just two nodes here. I am going to select this group input and press X on the keyboard to delete it. I am going to add a cube here through geometry node. I am in this geometry node panel, and if I press Shift plus A and I will come into search and type cube. So you have mesh primitives cube. So I will add a cube node and I will drag the mesh output and connect it to geometry. I have recreated the cube using this cube node. I will come into this 3D view. I will press the period key on my numpad. I am zoomed into this cube. I will roll the mouse down to slightly zoom it out. I will come here into viewport overlays. I am going to switch on the wireframe mode. You can see the wireframes here. I will come back into the cube parameters here. The default size is set to 1 meter, 1 meter and 1 meter, and the number of vertices along X, Y, Z is set to 2. I will select all the 3, drag it, and I will make it 3 and press enter. My cube is subdivided There is one level of subdivision, and you can see that every side of my cube has 3 vertices. To create the Rubik cube, the algorithm we are going to use is, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points on every side of this cube. I am going to generate a cube at every vertex point here. I am going to use the most popular node used in Blender, instance on point. So I will come back to my geometry node window, press Shift A, and in search type instance on points. I will drag this instance on point node in between this cube and group output. So automatically you can see mesh is connected to the point and you have the instance connected to the geometry. Right now, nothing is seen in the 3D view because I have created the instance point, but for every instance point, I have to give a geometry. Come into this geometry nodes panel, press Shift A, and in search, I am going to search cube, add a cube. So I have 2 cubes, and for the second cube, set its size, which is set to 1 meter. So I will select all the 3. I will set it 0.5. Because my original cube is 1, I will make this size exactly half. So I will make it 0.5. To give a gap between the cubes, I will make it 0.49 and press enter. I will drag the mesh output of this cube, and if I connect it to the instance, immediately I have my Rubik cube structure ready. So I have 9 cubes on all the sides. See, you can see the cubes created on all the sides. We have converted 1 cube into 26 cubes, and each side you have 9 faces. Let us first save this file. I will come into File, Save As. In my 2 Rubik Cube folder, I will name it as 1_RubikCube.blend and I will click on the Save button. Once it is saved, in this Rubik Cube, if you come into the Geometry panel and if you choose Rotate Instances and if you rotate it, my entire Rubik Cube is rotating at a time. According to the functioning of the Rubik cube, I want these Rubik cubes to rotate only in 2 axes. One is in the x-axis and another is in the z-axis. When it rotates, I want only the top area of this cube to rotate, and when I rotate it along the x-axis, only these cubes should rotate. This is a little complicated process. We can do it using mathematical calculation in Blender Geometry Nodes. So I will come back to Rotate Instances and I will set all the rotations to 0. I will select the first cube that I created. Press Shift D to duplicate it. I will just drag it and keep it somewhere at the top, and I will drag this group output. Temporarily, I will connect the mesh of this cube to my geometry. In the XYZ vertices, I will select all the 3 by dragging it. I will change it to 2. Now this is the default cube. I will press Shift A, and in search, I am going to search for mesh to points. You have this node mesh to point. I am going to select this and drag it and place it between the cube and the output. Every vertices of my geometry is connected into points. However, I doesn't want this to be vertices. So I will come in the drop down and select faces. And so now I have different faces here. I am going to attach one more node. I will press Shift A, come into search, and I will search for sample index and I will place it between mesh to point. Immediately the geometry output is disconnected. I am going to change this sample index from float to vector, and for value press Shift plus A, and in search I will select position node and I will connect this position to value. I will middle mouse click and drag it up, press Shift A and come into the search, and I will search for this index node. I select the index node with Control Shift press. If I click on mesh to point, these two are now connected to a viewer in the screen. Although geometry output is disconnected, you are viewing these face mesh points. I will connect the index to the second point here in the viewer. And if I come into overlay and if I enable attribute text, you can see the attribute number of every faces. Every cube has 6 faces and every face has an index number. I am now getting the index number of the faces. Close this overlay window. I will press 7 and come into the top view. I will select the annotate, and for 4 I will write 4 here. This is 5. I will write 5 here, and for 1 I will write 1 here. For 3, with shift middle mouse I will drag it down and I will write 3 here. So I got 4 faces, and to get the other 2 faces I will press 1 on my numpad and come into the front view. This face is 2, and with shift pressed I will drag up. This face is 0. I got an idea that each face of the cube represents. If I now middle mouse press and turn around, I can now just get an idea which face has which index number. So to get this value, I have added this index and viewer and I have marked it. Now once I am able to get this values, I will select the viewer and press X to delete. I will select index, press X to delete, bring my group output to the bottom, and I will connect the rotate instances to my group output. So I am back with my original Rubik cube. Now after this sample index, I will press Shift A and in search, I will search for separate XYZ node. I will drag it and I will take the sample index and I will connect it to the vector. So from here I am getting output of XYZ. I will select this separate XYZ, press Shift D to duplicate it. I will drag this group output a little to the bottom. I select the position, press Shift D to duplicate it, and I am going to drag this position to this vector. I have two XYZ output. Now I am going to compare the Z-axis values. Only both the Z-axis values are equal, only then those cubes has to be rotated. So I have to put a condition here. I will press Shift A and in search, I will search for a node compare. Utilities match. I will leave the value to float, and instead of greater than, I will select equal. I am going to test the Z of my actual cube and the Z of my position. I will compare these two, and the tolerance value I have set it to 0.001. If I zoom out now, I will drag this group output and this rotation instances till here. I am going to take this result, drag it and connect it to the selection. In this case, if I rotate along the Z-axis, you can see that only my bottom layer of the cubes are getting rotated. I will set the Z rotation value, say for example something to 45 degree. If I press middle mouse and turn around, you can see only the bottom set of cubes have rotated by 45 degree. Now instead of rotating bottom, if I want to rotate the next level, the control I have here is, if I come into this cube mesh to point and sample index, right now the value is set to 0. If I change this value to 1, you can see the next set of cube is getting rotated, and for the next set, if I set this value to 2, the next set is getting rotated. I can control which of these 3 cube set has to rotate along the Z-axis using the index value. I can set the rotation here along the Z. So here I can control the rotation. So this is for the Z-axis. I want the X-axis. So I will set this Z value back to 0, and the index value also I will set it back to 0. Now for the X-axis, I am going to repeat the same process. I will just zoom out and I am going to draw a box and select all these nodes connected to this rotate instance selection. So for this rotate instance selection, I have this cube, mesh to point, sample index, and 2 separate XYZ, 2 position and equal, and along with rotate instance, I select this entire block, press Shift plus D to duplicate, drag it and place it next here. I have made a copy of this and kept it here. Select this group output and bring it next to the second set. I will take the geometry output of the first rotate instance and connect it to the second rotate instance. So the selection is here and rotate instance, and I will now connect it to the output. And in the second case, instead of Z, I am going to connect X and also x. So I am going to compare x, and now if I come here and rotate along the x-axis, you can now see for index 0, only the center axis is getting rotated. So I will set this value to 45 degree. Instead of the middle axis, if I want to rotate the first one, I will come here and set this index value to 4. You have the first axis getting rotated, and if I set the index value to 5, you can see the next axis is rotated. So now when I am rotating it, every time I have to rotate it by exact 90 degree. So now I will set this value back to 0. I will come back, and in the z axis I will rotate it like this by 90 degree, and then along the x axis I will rotate it by 90 degrees. So I have no problem. So I will again set this back both to 0. However, instead of rotating z axis first, if I rotate x axis first by 90 degree, and then if I try to rotate the z axis, you can see the entire rotation is breaking. So I have to only rotate first z and then x. If I rotate x and then z, I will have the issue. So we have to solve this complicated problem. So I will set this value back to 0 and also this x rotation value to 0. To avoid this, we are going to enter into another important aspect of this geometry node, which we call as simulation. I will just zoom out and I will select this entire duplicated block here. I will select it and press X to delete it. I now have only the z-axis rotation, and I will connect this rotate instance to geometry. Now go to File and choose Save. For our next mission of solving this rotation problem, we have to store information of how much the cube has rotated in every axis, and we have to retrieve it. How to store this information? We are going to do it using simulation, and we are going to cover this simulation part in our next session.